Okay, for those who just arrived, I would like to ask your permission for the recording of the lecture. This lecture will be published on YouTube for all those who are as a recording for. So just say yes or just type yes on the lecture. Okay, thank you. We now proceed with the PowerPoint. Okay, now lesson 3, we're going to focus more on the network essentials. This is considering also subnetting. This is one of the this is the largest lecture notes we have. This is 80 slides, so possibly I could divide it by 2 today, or after that we'll have it tomorrow, or if we could finish it earlier, so we could have until Monday to discuss this. So these are the topics for your course. So we are now on the third topic. And the component in the lesson 3 is more on network hardware essentials. We have network topologies, IP addressing, subnetting, and applications of network subnetting. So do you have idea on the network topology? What are examples of network topologies? Anybody could answer. Okay, so network topologies are the arrangement of your network when you're going to perform certain communication route. So that's how network topology. Now for the basic definition in network hardware essential. So in Cisco Packet Tracer, we have 6 common components. So we have routers. These are typically have 2 or more network ports to which switches or hubs are connected to, and it's form an internetwork. So hubs and switches connect computers to local area network, and routers connect local area networks to one another. So later I will have a demo regarding this. And also we have a hub. Hub is a central connecting device for computers instead of merely a way of extend the network. And the third one is we have a switch or network switch is used to interconnect multiple computers so that they can communicate with one another. The fourth component is the domain controller. So computer running, especially in a Windows server, maintains a database of a user and computer accounts, as well as network access policies in window domain. So we have the fifth, we have the server. It is a operating system designed mainly to share network resources. A computer with the main role of giving client computers access to network resources, and a software that responds to requests for network resources from client computers. And the last is the heart of the wireless local area network is the wireless access point. So an AP is a light hub in that all computers send signals into the into it, and it communicate with other computer. So the obvious difference is that the signals don't travel through physical medium. It travels through airwaves using radio signals. So in on the image on the left, on the right side, so where is your router? Anybody? Where's your router on this side? This is a very important because you use this most of the time. Your router is this, you have this one. This is your router. And next, where is your hub? So number two, the hub is this one. So it's like a central communicating device. Okay. And next, where is your switch? So after the hub on the image, here is your switch. And this provides you communication between computer. And where is your network controller? So this is your network controller. So that is your network controller. And where is the server? So server usually is a cabinet. So a server is this image in your packet tracer. And your wireless access point. Where is your wireless access point? So this is your wireless access point. So you have a radio wave a signal image on the box. And what is this symbol? Anybody knows this symbol? Usually you use this at home. This is your, what symbol is this in your pocket tracer? This is your home router because you have wireless and you have router inside. So later we will have some examples on this. So what is the difference between the hub and a network? So because a switch is capable of forwarding frames to only a single port instead to all port, as hub does. So it can handle several computer conversation at one at a time, thereby allowing device full of network bandwidth. So the network bandwidth is required for sharing of resources. And when a device sends data and receive data simultaneously, it's called full duplex. If the data can send or receive, but not both at the same time, it is called a half duplex. So hubs operate only in half duplex, while switches operate in both ways. And also, the performance advantage of switches made them the choice in the networks of all sizes. So now we go to the so last time we discussed local area network, wide area network, metropolitan area network, and these early networks didn't use interconnecting device, but they are using a daisy chain. So wherein it is being attached to the network interface card at the back. As you see, the computer, you have this, but this is only hub connection, meaning when this fails, your connection to the next computer will also fail. But on this side, since the failure was being held here, so you have still a communication on this computer. Now, we also have this term. It's used to extend our connection. It's called a repeater. So repeater is the same as your wireless access point, and it is also it doesn't strengthen the signal, but it instead it's the signal is being amplified. So it takes the weakened signals and repeat the original signal strength. So it repeats the signal, but it doesn't strengthen the signal. So that's the difference between strengthen and repeating the signal. Also, we have these multi-port repeaters and hubs. So a multi-port repeater is just a repeater with several ports that you could connect cabling, and the most multi-port repeaters have at least 4 ports. So as you notice, you have it on your computer. So your home router does have a 4-port for your Ethernet. And how does a hub performs on this? So a hub performs the same function as repeater, but with more outgoing ports to which bit signals are repeated. So at first, it received the signal and it generated from connected computer on one of its ports. And also, it cleans the signal by filtering out the electrical noise, and it generates the signal to full strength. And also, the last is it transmit the regenerated signal to all other ports, a computer, which is connected to. So what is a network bandwidth? So network bandwidth is the amount of data that can be transferred on the network using a specific interval. It is usually in bits per second. So a network operate at speeds of 10 million bits per second, and it's about 10 megabit per second and up to 10 gigabit per second. So this bandwidth is determined by how fast the network devices can send bits of data to the medium. So a 10 megabit per second hub, for example, transmits a bit at a rate of 10 million per second. To put this rate into perspective, two computers connected to 10 megabit per second hub can copy 1 minute of MP3 music, so to each other about 1.2 second. So, but 100 megabit per second hub can transfer the same amount of information about eighth of a second. So that's why 100 megabit per second is faster to this rate. Okay, so this is an example of a Pocket Tracer hub. So you have this Ethernet, and you could add another option here, what connection device you would like to add on. And this is the power on button. So if you're going to add a component here, you need first to turn off the power, and you could add. So what is bandwidth sharing? Because all computers connected to hub, they must share amount of bandwidth. So the hub provides example 10 computers connected to 10 megabit per second hub. All 10 computers are trying to send receive files frequently. Because the computer must have the share bandwidth, the average bandwidth for each is only 1 megabit per second. So that's why the transferring of 1 minute MP3 takes more than 12 seconds if you have 10 computers, because it's going to divide all the components inside. That's why using hub will take time. And also, we have a hub indicator. So this generates green for 100 megabit per second, amber for 10 megabit per second connection. So this is your physical hub as you see on the actual. Now for basic switch operation. So again, switches operates when using a switching table, but this your physical address is your MAC address. some your media access control. So example, so we have AAA. So this A hex, A1 hex is connected to your port 6, correct? And your B hex and B1 hex. So this connected to your port 1. So this means that they are having to identify which port the switch is connected. So for example, so data is sent to the medium one frame at a time. So the beginning of each frame contains a destination computer, physical address or your media access control, and the source computer, MAC address. And when the frame reaches the switch reads both addresses by reading the source MAC address. So then the switch keeps the record of which port. This function referred to as learning. So your switch try to learn that this is the port that you are referring to, and it creates a table so that it would be easy for it to transfer or to connect to another computer. By reading the destination MAC address, the switch can forward the frame to the port and the destination computer is on. So the switch maintains a switching table. So this is a switching table inside the switch. So it lists the MAC addresses that have been learned and their associated port numbers. So that's a switch. And switch also is capable of forwarding frames to only a single port instead of all port. So because hub do by sending in all ports, so it can handle switch can handle several computer conversation one at time, one time by thereby allowing each device to full network bandwidth. So dedicated bandwidth instead of requiring bandwidth sharing. So in other words, if a switch in figure 21 is a 10 megabit per second, if this is a 10 megabit per second switch, so we have computer A communicate with computer C with an uninterrupted 10 megabit per second rate. Also, computer B and computer D can also have the same communication. So later, we'll try this in a switch. And furthermore, each computer can receive data at 10 megabit per second. At the same time, it can send data. And when a device can send data and receive data simultaneously, it's called a full duplex. So this. So we have switch indicator lights on switch. So this is an example of a switch. How many ports does it have, or this? So, so how many ports do we have here? So you're just going to count 1, 2, 3, 4, 5, 6. So times 4, you have 24. So this is a 24 switch port. So uplinking, the term uplinking is making connection between devices or two switches, usually for the purpose of expanding the network. So also we have this example, uplinking. Next week, we'll have this because I have also some exercises on this, on subnetting. And for your laboratory module, so you're going to have this simulation using packet tracer. So first, you're going to communicate computer to computer using crossover cable. Next, you're going to connect a router to router. Uh, if you could connect this to another router, connecting switch to a switch, hub to a hub, and this router to a PC. So you will also take note of this because these are important. So this is the summary for crossover cable, and this is the summary for straight through cable. As you noticed yesterday, we try to make connection between computer to a computer using straight through. So what happened? Can we communicate? So we did not communicate because crossover cable only requires a computer-to-computer connection, while a straight-through doesn't allow computer-to-computer connection. The same with these other connections. Also, this is now this is just a review for your test, okay? And these are the things that you're going to do. Uh, so we will try this, okay? But the IP address, you're going to set up the IP address. I will just going to give a different example. Okay. Okay. Open your Cisco Packet Tracer. Okay. Uh, can you see Network Packet Tracer now on my screen? Okay. Thank you. So we will have this. I go back to the screen. Okay. So we will have an example. Okay, we have example switch, and we have computer, we have PC. So it's just a drag and drop. So recall that a switch can communicate by what what connection we will put. So you are going to select these connections and what cable we're going to use. What cable we're going to use for this connection. Yes. What did what cable are you going to use? So go back to your PowerPoint. So we will use a crossover or what? Straight through, right? So the symbol for crossover is this one and straight through. Since we are going to connect unlike devices, so what would be the connection? So this is by this one. So you have, let's say, use two, and this as Ethernet, and three and this, and this. Usually, I reserve the first port to your router. Okay, so this is a basic connection, and I usually reserve the first where we can we find the router. So you go to click here, and you have we have 960 Cisco 24 port. So you're going just to search. So if you find this port, so you have so you have example, you have this packet tracer router. Could use this also. So let's say this one, and what connection you could have here. You will have what this also. Okay, so your first port will be connected to your router. That would be your. So that's it. So that's how you create a connection between router to switch and this one. Also, you could have another connection using crossover. So likewise, you could have this example. Okay, hub. Got a hub here. And you could connect this one, your fast Ethernet 6. So you have this hub. So, and connect to this one, and this. So, in this example, you could connect so many ports in a switch. Okay. So because you could have like 24 connections. So that's it. So that's how you connect. But take note, on your exercise, stop sharing. We have this. Your PowerPoint. Okay, here. So take note of the instruction, and also this is just an example of IP address that I'm going to give you, but on the Google Classroom, you will have a different IP address to set up. Okay, so in this case, so after you made the connection, you will change the IP address from this range only. So okay, let's try to do another example. But this is only what is the requirement? So you have either a hub or a switch that you're going to connect three computers. Okay. So let's try to stop sharing and try to. So let's say if yeah, we want a new one. Okay. So we have a new. Yes. So we're going to create a new second. Okay, I'm going to look for an example that you could be able to uh, see. These are one of the things that we are having. Okay, so I think I'm. Can you see what we have now on the board? So when you open a file that you have made previously, so what happened is you could not simulate. Uh, you could not simulate easily, but you need to wait for a few, maybe seconds. Then when you see all of the connection are green, so you're going to start the simulation. But since we are not yet on the simulation side, what we are doing is that we are on the configuration of your IP address. Now, in this example, we have IP address starting from PC0. That is, if you're going to double click here and you click configure, you'll see the default gateway that is this one. This gateway being shared by two switches. And so that you could be able to share, you must have the same gateway. This is communication between two switches, and this one communication between a hub and a switch. That is in crossover, and this is in straight through. So what you're going to do is go to the desktop and check the IP configuration, and you will see this class A configuration. So this one is this IP address. This is the IP address of this PC. The IP address of this one is this one. To create label, you need uh, to place node, and that's it. So that's how we configure. So you click. Sorry, I cannot. I will change because you cannot see the window, I think. So once you click the window, there will be this first tab will appear. Then you will know your gateway is this one, and your desktop. This is manually set up. So this is PC1, and this is the auto-generated subnet mask, and this would be connected to gateway as we see here in the configuration. This is the gateway. So these two are just the two tabs that you're going to use for this moment. But on the example, you have 192.168. So it depends on the range that I'm going to give you. So we now go back to Packet Tracer. And how will you know that this is in good connection? So for example, I will turn off. So take note, you have red. So meaning when you simulate, uh, this simple PDU. So this to this, maybe, and so, and we try. So that's how you simulate. Uh, that's how data being distributed. Take note, if there is red fire ongoing, that is a collision, and if there is X, meaning that is not successful. But if you have a check, meaning that is both of the computers able to send and retrieve information. So we have retrieve information from this computer, I think. And the second PDU will now move forward. And is it here or here? I don't know. So it doesn't give on the hub. Maybe on this side. Okay, this is successful because it's going to return back to the sender. So the message from this is successful. That's how we start with switches. So this is a simulation of switches, and this is the last PDU that we try to send. So it must be. So what have you noticed in Hub is that it broadcasts all the data to the computer. So that's the difference between a switch and a hub. While a switch only specify which computer will it receive, right? So this one does not receive here, but on the specific location. When I send a certain packet here, all of this will be broadcasted. So for this one, this is just the last part of switches when they try to interrupt every communication. So do not be confused if your switch distribute data, because a switch cannot distribute data. It's just like it's part of the simulation itself. Okay. So we move to our lecture. So any questions regarding your module 6? So no questions. So we move forward to our PowerPoint. So this deadline will be, I'll have this after the class, and this deadline will be on next week. Okay. So we have the hardware network essentials. So this is your wireless access point. So as we discussed earlier, this is a common home router in your home. This one is your repeater or access point, which only what? If you connect this to this, you will able to extend your wireless signal to your home. If you have another uh, room that doesn't receive wireless internet, so you could use wireless access point or repeater to extend or to repeat the signal itself. And also, we discussed already the network interface hub last time. And this is what happens in your network interface card. So first, it receive incoming bit signal from your network medium. So from your cable, and you have this destination MAC address that is inside your frame header, and it contains source MAC address also. And this time you have also IP protocol or your network protocol that is destination, and you have a source IP. So this destination IP is your like we simulate earlier. This the location that you will going to send the data, and the source IP is your the one that you have ID. So then in this way, it converts bit signal into frame and verifies the MAC address and removes the frame header. So this one will be removed, and the trailer also. We use this cyclical redundancy check to check errors in the frame, and also it sends a packet to the network protocol, and in this time it verifies the CRC if it is a correct if we have the correct data from our correct IP from each other. So there is error check so that we could transmit data. And after that, this is from your incoming data from your network medium, and we now move to the outgoing data. So as an outgoing data, so we start at the top. So from your incoming, so this is your outgoing data going to the next computer, and it would receive the packet from your network protocol. This is the packet from your network protocol, and it adds the header and trailer. This one is added and converts them into frame, and it will be transmitted to the cable, this one, to your computer. So this is your how your network interface card incoming and outgoing process happens inside. So as we know, we have bits of information. So now we have routers. So routers enable multiple local area network to communicate with one another by forwarding packets from one LAN to another. So this is example of a modern router. This is not common to home router because this one is a gaming router, which you intend to connect to game servers. So switches, they maintain a switching table. Also, router have its routing table. And routing tables are composed of IP, network address, and interface pair to determine where to forward packets in the internetwork. So a router have two or more interfaces. With each interface, it's connected to a different network. When a router receives a packet on one interface, it looks at the destination IP address in the packet to determine which network the packet is addressed to. So then it forwards the packet out of the interface, and its routing table indicates its best way to get the packet to its destination. So we have here, so how do we attach a network interface card to create a mediate connection between a computer? So on your Pocket Tracer, I will try to demo. Now you're going to end, I think. So good. Okay, so another demonstration for your. Okay, so this one, share. Okay, so for your computer. So we have is physical. So how do we put so this is an example of network interface card, microphone, headphone, but I don't want to put this, but I just have huh. So this so this gigabit internet. So this is this one. Okay. First thing first is to turn off and you put this one. So that's it. And on. So the same if you put to another device here. So this gigabit Ethernet module, network module. So we will try if it is on, you put, but it will appear that you need to turn off. You see, you cannot add a module when the power is on. So only you will turn off, and you have this. Okay, so that's how you add a network interface card. And as you see, if you change something inside, meaning it would also affect this. So how do you remove? So just this one and on, then and this one. If you turn on this, okay, this on. Now you will see it's going to reset, and when you see a yellow dot, meaning it tries to reset the configuration, and in turn it would be back or to establish the connection again. So, any questions on the configuration of the devices? Let's say the server. So, so this is on the server side. So we have to zoom in. Also, when you try to drag this, you see you cannot add, but you turn off. Okay, so this. So you have a wireless 3G, 4G connection on this side. So that's how you establish. So at the end, you will have this project, but it will be randomly selected which project you're going to have. So you cannot have all of this as a project, but maybe smart or IoT, you could have it. Okay, so we move forward to the summary. So the difference between the hub and switch is the hubs work only with electrical signals and the bits these signals represent, whereas switches work with actual information. These bits combine to make frames. Like repeaters, hubs requires power to operate, So they sometimes referred to as active hubs. But this term isn't common because unpowered devices known as passive hub aren't used for the same purpose. And network hubs are where mainstay in the connecting computers in a local area network for several years. But although you could still find hubs in the workplace, they're becoming obsolete. So most commonly now we use a switch. So what are the switch operations? First, we have a switch receive frame, and the switch reads the source and destination MAC address, and the switch looks up the destination MAC address and the switching table. The switch forwards the frame to the port where the computer owning the MAC address is found. The switching table is updated with the source MAC address and the port information. And also, we have discussed the network interface card. We have the NIC and the MAC. So you could see the manufacturers on the back of the NIC or on the and MAC address is also being distributed on each computer. And MAC address is stored in a read-only memory because the address is burned in the memory and referred to as a burned-in address. So this means it's unique. So it's a every devices you have, like your cell phone, mobile phone, have its unique MAC address because that is in hexadecimal numeric hexadecimal number. So you could have a lot of combinations. So network interface card is a gatekeeper. So it simply read the frame and send the packet to the network protocol and examine incoming network frames and checks the frame destination MAC address to see whether it matches its built-in MAC address. The NIC acts as a gatekeeper and permits inbound communication to pass through the interface only if the destination MAC address meets these criteria. So the destination MAC address in frame matches the NIC, and in MAC address, the destination MAC address in frame is broadcast address. So the NIC is operating in a promiscuous mode. And I think we end our lecture here and we will continue this tomorrow. So hoping to end this, we are on slide 25. So any questions before I end the recording?
Sir.
Okay. So thank you for attending the class and we'll continue tomorrow. So I'll not give you